Hello, this is Don Machholz, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 10 for the week of March 10th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. So, what's up in the sky this week? As we begin our week on Wednesday, March 11th, the moon is 2 days past full. And over the next week, it will be in the morning sky, moving towards third quarter. So it will be in the morning sky all week. On Wednesday, March 18th, the moon occults, or passes in front of, the planet Mars. But the actual occultation is only seen from deep in the southern hemisphere and then from Australia to South America. Venus hangs in our southwestern evening sky. With no moon in the sky this week, and with Venus now shining magnitude minus 4.3, let's try again to see a shadow cast by the light of the planet Venus. We tried it a few weeks ago when Venus was a bit fainter, and we'll try it again in a few weeks when Venus is near its brightest. But let's see what we can get now. There's a couple of ways to do this. You don't even have to go outside. If you have a westward-facing window and can darken the room, this will work too. And inside a dark room in your house might be darker than being outside in a somewhat light-polluted area. A dark environment is important, as contrast is the name of the game. So go into the room, open the shade or drapes, and let Venus's light fall on the wall opposite the window. Close the door to the room and turn off all the lights and make the room as dark as possible. Let your eyes get accustomed to the darkness. Now go over to the wall and look carefully for variations in brightness on the wall caused by the window frame blocking some of the light from Venus. We're looking for a faint but distinct shadow. If you see nothing, then try this. Wave your hand back and forth between Venus and the wall and look for the shadow of your hand. If you try this outside, use a wall on which to cast the shadow or a sheet of white paper. Also in the evening sky, we have our old friend Betelgeuse. Reports are now that the star is brightening, and I've seen this with my own eyes. You can make magnitude estimates of the star Betelgeuse yourself. You can use Podcast 10, Star Map 1. Look at Betelgeuse and make an estimate of how bright you think it is. Watch it as it continues to brighten over the next few weeks. One study just done recently seems to indicate that the dimness that we saw and the dimming of the star Betelgeuse was caused by dust and clouds between us and the star Betelgeuse in the vicinity of Betelgeuse. And so possibly the star itself wasn't dimming, just that we could not see it as well because of an obscuration between us and the star. That's somewhat similar to your car headlights not being as bright because of a film on your headlight lens. Our morning sky has the planets Mars, Jupiter, and Saturn, plus the moon this week. As stated above, March 18th, the crescent moon passes both Mars and Jupiter. It will pass in front of Mars as seen from a small portion of the southern hemisphere, so most of us will not see the occultation. Nevertheless, as the moon continues to move past Mars and into the vicinity of Jupiter, and Mars and Jupiter will be very close to each other on March 18th, This makes for a tremendous photo opportunity. The Moon, Mars, and Jupiter in very close proximity to each other on the 18th of March. And 2 days later, on March 20th, Mars and Jupiter will be at their closest approach, but we'll discuss that in next week's podcast. The International Space Station is visible depending upon your location. North of about 50 degrees north latitude and south of about 10 degrees south latitude, you won't be able to see the International Space Station this week. The rest of the Northern Hemisphere has morning sightings until about March 15th, then mostly evening passages. To find out when it will be in your sky, go to the website heavens-above.com, enter your location, and find out where and when to see it. Let me start out this next segment by saying that I do not like to be cold. I can handle the heat better than I can handle the cold. Cold is somewhat painful to me, and when my fingers and toes get cold, and those are the first two things to get cold, I'm in pain. I do not like that. I could handle it in my early astronomy days, and even when I began comet hunting in January of 1975 and was observing from my backyard in Concord, California. Comet hunting sessions were about an hour long, and I could simply go into the house if I got cold. By November 1975, I started commuting to locations near Concord, but further from the suburban lights, usually within 10 miles of my home. Comet hunting sessions increased somewhat in length, and I began to experience cold fingers and toes during some of those sessions. Comet hunting is a very sedimentary process. You do not move much for hours at a time. The only astronomical job that requires less physical activity is guiding a guide star through your telescope for a long exposure photo, something that has since been automated. In March of 1976, after my brother passed away, I moved to the San Jose, California area and began comet hunting from a mountain called Loma Prieta in the Santa Cruz Mountains at an elevation of about 3,400 feet or 1,000 meters. It was 35 minutes from my home in Los Gatos, California, and with a long commute time, I found myself staying at the observing site for 2 or 3 hours at a time. And at that elevation, it could get cold and windy. I recall a few times that frost would accumulate on the back of my one-piece observing suit. For my hands, I found some very thick and warm mittens, and those mittens with glove liners underneath did a fairly good job of keeping my hands warm. But what about my feet? I tried wearing a lot of socks, up to 7 pairs of socks at a time, and some very large shoes. Size 12 shoe was the largest that I could find in those days. That helped, but I had very little toe wiggle room and sometimes got sweaty feet, which did not help with the warmth factor. Somewhere along the way, I learned that they made electric socks running on battery power, the battery packs being up around the upper ankle area. I bought a pair and found that they did provide some warmth, but not a lot. The batteries would die after a few hours, and the expense began to make this an undesirable solution. I even tried a larger 6-volt lantern flashlight battery, but it had to be replaced every week and was not rechargeable. Being a guy who thinks that more is better and bigger is better, I took a quantum leap. I purchased a huge 6-volt battery, the type used for golf carts or small cars, one that can be recharged with a car battery charger, and I used that to heat my socks. But it took some further development in the wiring system. First, I went from 7 pairs of socks down to only 2 pairs of socks. 1 pair went onto each foot. Then the wires went over and around my feet, especially the toe area. Then another pair of socks went over that bird's nest. In practice, I removed and put on both socks together with the wires in between. So far, so good. The speaker wires for each foot were soldered together at the lower end, so current going down one wire would come back the other wire. It was like a big resistor, and the current produced heat. As the 2 wires emerged at the top of my foot, I had 2 alligator clamps, 1 for each wire. So each foot had 2 alligator clamps sticking out. Now what? I could not carry the large battery in my pocket. So next I had a larger gauge wire, which would conduct very little or no heat, running up each leg and out the waistband of my pants. These larger wires also had alligator clips that clipped to the clips at the top of my socks. As the wires emerged from the top of my waistband and out the pocket hole of my one-piece suit, right-hand side, it had a plug which plugged into a small hand-sized toggle switch by which I could turn on and off the socks. Then I used 2 8-foot extension cords, special wire called HPN wire for high current, which ran to the battery, and the battery itself sat on the corner of my drop sheet. So I was tethered to a battery. This was in 1978. In fact, my notes state that I used them, perhaps for the first time, the day before I discovered my first comet in September 1978. When I give a lecture on my comet hunting, I show a photo of me sitting at Loma Prieta at night with the wires coming out of my pocket and into the battery. It is important at this point to say that if the power was left on, it could burn your feet in about 20 seconds. Under normal operating conditions, it worked quite well. Every 10 minutes or so, I would give it 15 seconds of heat, and that kept my feet warm. Seconds after turning the switch on, I could feel my feet warming up. But I had to be sure to turn it off before it got too hot. I recall at least 2 instances in which I burned my feet. Once when I failed to get my hand back to the switch in time because I was busy adjusting the telescope or something, and that one really hurt. The more severe time was the morning the switch burned out and stuck in the closed position. I'll never forget that moment. I flipped the switch to on, and my feet began to warm. After about 15 seconds, I flipped the switch off, expecting the warming to stop. It did not. It took a few lame moments on my behalf before I realized that, hey, my feet are getting hotter. I turned the switch on and off a couple of times with the same result. My feet were burning up. Finally, I unplugged the cords, and by then I was in terrible pain. I started hopping around on my heels like they do in cartoons when they blow their foot off, but for me, it was both feet, and my toes and bottom of my feet were the most affected. No blisters, but red skin for a few days. Okay. So I had a few mishaps with the socks, but all in all, they did a rather good job of keeping my feet warm. My next problem was that on occasion, my eyepiece would get fogged up due to my body heat as I hunted for comets. Visual comet hunters generally keep their eye to the eyepiece for nearly the whole time, taking it away in only a few types of instances. 1, for perhaps 10 seconds or so when we get to the end of a sweep and reset back to the original declination and start another sweep, or 2, to check for a suspect fuzzy object, referring to a star chart or catalog for up to 10 minutes, or 3, short breaks for a drink or bathroom. It is during those times that the eyepiece can chill out. Then when one returns to it, Their body heat and humidity can fog up the cold eyepiece. This is more apt to happen when I took steps to keep stray light off the eyepiece. That is, using an eyepiece shield or even a cardboard box with a hole in it for the eyepiece to stick through. I've tried several methods to keep stray light off the eyepiece while comet hunting. In 1992, when I discovered my 5th comet, and in 1994, when I discovered my 9th comet, I had a small blanket over both my head and the eyepiece to keep it dark. So I decided another set of wires to warm the eyepiece. They required a second set of wires coming out of the battery and another on-off switch running to the wires wrapped around the eyepiece and kept in place by a tube of elastic fabric. And guess what? The finder would sometimes do over, so I put some wires inside the finder tube. Once again, it had to be turned off after 15 to 25 seconds, lest it get too hot. Unless my eye is at the eyepiece and I could feel the wires warming, I simply had to remember to turn it off in time. This worked rather well, but guess what happened to this setup? You are right. I left it on too long one evening. I think I kind of forgot that I had turned it on, and the next thing that happened is that I hear sizzling wires inside my finder scope. And then the wires around my eyepiece began to melt together. Well, the wires did not melt together, but the plastic insulation around them melted. I unscrewed the front lens of my finder and smoke poured out. Fun with electricity. I used my battery-powered warming system for a couple more years, but never again put wires into the finder scope. Live and learn. For these next 2 items, you might want to download Podcast 10 Map 1 from my website. My website is donmachholtz.com. That's Podcast 10 Map number 1. With the moon out of the evening sky, our unaided eye and binocular challenge this week is the Beehive Cluster. It's an open star cluster. It's also known as M44. This cluster is the 44th object in the Messier catalog, but it wasn't discovered by Messier. It's been known for thousands of years. It's 577 light years from us and about 7.5 light years across. In our sky, it's about 1.5 degrees across. Now, a few weeks ago, we observed the Hyades open star cluster near the star Aldebaran. This cluster, the Beehive, may be related to the Hyades. With the unaided eye under dark skies, this cluster should be visible to the unaided eye as a faint, fuzzy patch. It appears fuzzy not because it has nebulosity, but because all the stars blend in together to the unaided eye. So go out and look at the Beehive cluster. Using a pair of binoculars, the Beehive cluster resolves into individual stars. This was one of the first objects Galileo observed with his telescope in 1609, and he observed about 40 stars in the cluster. You might notice stars of different colors here. How many stars can you see in the Beehive cluster in your binoculars? Our telescope challenge for this week involves 3 comets that we will look at both this week and next week. Now, last week when I closed the program, I said we'll be looking at 2 comets. I had in mind also a 3rd comet, but I wanted to see what would happen in the intervening week. That 3rd comet has brightened up and is looking rather exciting, so we'll be looking at 3 comets this week. These 2 maps, Podcast 10, Map 2, and Map 3, can be used for the next 2 weeks when the moon is out of the evening sky to help you find these comets. On these maps, tick marks are made for each day of the comet's position at 0 hours universal time. All 3 comets are in the northern polar region, and you do need a telescope to observe them. Now, these are the 3 comets. First, we revisit Comet Pan-STARRS C 2017 T2. This is still our brightest comet, at about magnitude 9. It reaches its closest point to the Sun on May 4th, then it will be 150 million miles from the Sun, and it will remain in the polar region, northern sky, and in the evening sky through July. It was discovered in 2017 by the Pan-STARRS program in Hawaii. Comet Pan-STARRS is presently, as I said, about magnitude 9. It's not expected to get much brighter. Our next comet is Comet Iwamoto, discovered January 8th of this year. It's also known as Comet C/2020A2. In podcast 3, we discussed the discovery of the comet, and at that time it was magnitude 12. Well, since then, it's moved north and has brightened to about magnitude 10.5. Again, you'll need a telescope to see it, and it is slowly dimming. Our third comet is Comet 2019 Y4 Atlas. It was discovered by an automated sky survey in Hawaii on December 28, 2019. Now, ATLAS stands for Asteroid Terrestrial Impact Last Alert System. When the orbit for this comet was determined, it was seen that the comet will get close to the Sun, 4 times closer than we are, in late May of this year. So it's moving rapidly towards the Sun, and in the past 10 days has brightened from magnitude 14 down to about magnitude 11. The comet's orbit is similar to the Great Comet of 1844, and it is believed that they are related. Perhaps they broke off the same original comet. But they are not the same comet, as this one has an orbital period of about 5,000 years. The comet will get brighter and eventually move southward, with our last good view, at least from the northern hemisphere, being the 3rd week of May, when it will set in our evening sky about 90 minutes after sunset. By then, it might be visible to the unaided eye, at least expected to be visible in binoculars by then. Then it gets within about 10 degrees of the Sun and moves into the morning sky south of the Sun. And now the southern hemisphere is favored to view the comet, but it will be difficult because it will be close to the horizon at dawn. In fact, it stays within 30 degrees of the Sun through June and for much of July. And then during those months, it will dim. Presently, it's in our northern evening sky. You can find daily positions on podcast 10, map 3, where it's plotted for each day at 0 hours universal time. It passes 4 degrees south of the galaxies M81 and M82 on March 16th. Follow it for the next few weeks and watch this comet develop. Now for fun with the marathon. More than 200 years ago, an astronomer named Charles Messier made a list of 110 galaxies, clusters, and nebula that were visible to him as he went about his comet hunting. The Messier Marathon is a yearly activity to observe all, or nearly all, of these objects in one night. Now, this can be done any time of the year, and you can get at least 90 objects in one night any time of the year. But the best time to do this is in late March, and it does depend upon the moon phase. So with new moon on March 24th, most astronomy clubs will be doing the Messier Marathon on either the 21st or 28th of March. Now, to successfully run the marathon, it helps to have an observing order. You can download it from my website. It's podcast 5, Search Sequence. You will also want to download a map, podcast 10, map 4, 8, which shows the 13 Messier objects that we'll be discussing this week. When we left off last week, we had seen the 4th set of Messier objects in the Messier Marathon and have covered 87 of the 110 objects in the evening sky, and then we moved over to the morning sky. This week we're covering 13 more objects, which will take us up to 100 of them. Podcast 5 through 11 trace the Messier object's search sequence from the first object we find and observe during the Messier Marathon to the last one. This is podcast 10. And if you download all the Messier Marathon maps from episodes 5 through this one, and then next week download the final installment of the search sequence, you'll have the maps and the search sequence for the Messier Marathon later this month. We now tackle what is known as the Summer Milky Way. We start with M11, also known as the Wild Duck Cluster. This is wonderful in any telescopes. It especially pops out in large telescopes as it has several thousand stars. Next, we slip down south and slightly west to M26. This is a smaller and fainter star cluster. It tends to blend in a bit with the background, so be careful on finding M26. M16 is the next one. It's known as the Eagle Cluster, and the Hubble photos of this cluster and nebula became known as the Pillars of Creation photo. To get to it, we continue south and slightly west from M26 to M16. Next, just south of M16 is M17. It's also known as the Swan Nebula. And just south of that is M18, an open star cluster. Our next object is a unique object on the Messier catalog. It's not really a star cluster or nebula or galaxy. It's a star cloud. It's known as M24. It's a bunch of stars, kind of a detached portion of the Milky Way. It measures about 1.5 degrees by 1 degree in size. There is a small open cluster known as 6603 sitting in the star cloud, but that open star cluster itself is not M24. M24 is a star cloud. M24 is quite an impressive object. At some of our public star parties, this would be sometimes the last object that we would show. From M24, we go east to M25, which is a rather large open cluster, then back to M24 and go in the opposite direction, go west to M23. Now this is another open cluster which is dimmer and a little bit smaller than M25. Go back to M24 and then go east and south to M21, a small open cluster, and this one does stand out against the background. The next one is just south of it, which is M20. That's known as the Trifid Nebula, and it's a nebula with many stars embedded. You continue further south, and we find another nebula with an open star cluster involved. It's known as M8, also known as the Lagoon Nebula. Two more objects remain in this sequence. M28 is a globular cluster. Its magnitude 8.4 and only 5 arc minutes across, but it does stand out against the background. And then finally, we come to one of the brightest globular clusters in the sky, M22. It is 3 magnitudes brighter than M28 and 3 times larger. So there you have it. The first 100 objects in the Messier Marathon. You've covered 91% of the Messier catalog. By now, we are in the pre-dawn hours, and you may be waiting for the final objects to rise. You have been listening to Looking Up with Don, podcast episode number 10. The related website for this podcast, where you can get all these free star maps, is donmachholz.com. That is spelled DonMachholz.com, 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky. We'll have our last segment as we work our way through the sky with the Messier Marathon. We'll take a look at zodiacal light. We'll discuss the spring equinox. We'll take a look at some bright double stars, and we'll discuss public star parties where astronomers set up their telescopes for the public to view the heavens. Thank you for listening. See the sky this week. I'll see you next week.